Here's a nice problem for you guys about coordinate geometry. The set of all values of a squared for which the line x plus y equals 0 bisects two distinct chords, drawn from a point p equals 1 plus a all over 2, 1 minus a all over 2, on a circle 2x squared plus 2y squared, minus 1 plus ax minus 1 minus ay equals 0 is equal to. Okay, so like this problem might seem a bit obscure, so we might have to draw it out first. Two distinct chords on a given circle. Let's just try. Oops. Given a point P, draw two distinct chords. At random, I'm drawing them here. And then if this line x plus y equals 0 bisects the chords, that means that it cuts them at their midpoints. So right away, we see that the line through these midpoints is not going to be x plus y equals 0. So okay, this is how we can get a sense of the situation. So okay, so like we might wonder, what is the locus of the midpoints of the circle passing through P and these midpoints? So let's try it out. Actually, it's a neat geometric proof. So like Hubble circle, but imagine with this fixed point P, and then we have this chord whose endpoint we'll call A, and then we have this midpoint M. Now we can do construction. Draw P to P dash, the diameter of the circle. And of course, there's a center O. And of course, angle P dash AP will be a right angle, like so. And because M is the midpoint, I'll just, it's not good, but yeah. We can also see that P dash O equals O dash P, OP, P dash O equals OP by definition of the radius. So what this means is actually this triangle here is a dilation of the original triangle P dash AP by a scale factor of 1/2. So that means this angle, these two angles, P dash AP and O MP are both right angled. And so since we chose A arbitrarily, by Thales theorem, we have that M must lie in the circle with diameter OP. And since like A was arbitrarily chosen, this blue circle is the locus of the midpoints of circle. Um, the locus of the midpoints of chords in a circle that was already originally given. So now back to a problem. Let me just erase this indicative. Let me just erase this indicative diagram if I can figure out how. Right. Right. We know that P is given, so we definitely need to find the radius of the original circle. So we can have it to find the radius of this blue circle. And then we also need to find the center. So how we're gonna do that is trying to find the center. Uh, center and the radius. So what we're gonna do first is divide everything by two original circle equations. So that's x squared plus y squared minus 1 over a on 2 x minus 1 minus y over 2y equals 0. Excuse my handwriting here, but yep. And actually it turns out when we put this into standard form, we get this over here, this equation. Um, and so given that original point P is 1 plus a over 2, comma 1 minus a over 2, and this original circle has center 1 plus a over 4, comma 1 minus a over 4, this red point will be the midpoint, which is 3 times 1 plus a over 8, comma 3 times 1 minus a over 8. So these are coordinates of this center here, and of course you just divide by 2. So like because this is r squared actually, when we divide r by 2, r squared will be divided by a factor of 4. So this is why this is the new radius. Okay, so now back to our problem. Um, we we're going to need a distance formula actually, because look what happens if we have this um, circle uh, where P is somewhere here, and then we have this line which is x plus y equals 0. The limiting case, when these two intersection points of the circle, like if the circle bisects, um, if the midpoints in the circle bisect, we have these two intersections here. But then when these two coalesce into one, this circle will be tangent to the given line and to the circle, like somehow like this. Yeah, okay. And of course, in any other case, the perpendicular distance from the circle's center to the line will be less than the radius. Okay, so we actually need a distance formula here. So this will be given the line AX plus BY, sorry, one sec, plus BY plus C equals 0. The distance to a point x0, y0 will be ax0 plus by0 plus c over the square root of a squared plus b squared. So this is our distance, the perpendicular distance. Right. So from this, we know that a is 1 and b is 1. So that's good. And we just have this point 1 plus a on 2. No, that's not right. We have a midpoint um, 3 times 1 plus a over 8, comma 3 times 1 minus a over 8, which is this midpoint here. Um, so 3, 8 plus 3, 1 minus a over 8, and then c is 0 from the above. There's no 0 term here. So that's plus 0, so just 0. And then of course, 1, a is 1, b is 1, 2, square root 2. It's going to be less or equal to the radius of the circle, which we found from before was the square root of 1 plus a squared all on 32. So actually what we can do is just take this 32 out, And then we have the square root of 1 plus a squared. So cool. So we just this will actually take the absolute three take the fraction out of the absolute value, and 1 plus a over plus 1 minus a is just gonna be 2. So I mean that the absolute values just drop out. And then here we can simplify 1 over square root 32 into 1 over 4 times square root 2 plus over 1 plus a squared. And this these square root 2's cancel, and then multiplying by 8 on those sides, we get 2 here. So actually, when you write this out all out, 3 is going to be just less than the square root of 1 plus a squared. And it's very simple algebra at this point. We can split both sides because these both sides are non-negative. So that gives us 8 is less than a squared. And this is our range for the values of a squared, as you can see in the original problem. Alright, I hope that helped answer this coordinate geometry problem. I hope you're also looking forward to better content next time. Okay, peace out.